previous video, we introduced how to factor out a greatest common factor from a polynomial. Well, here we're going to give you more examples. So whenever we have a polynomial, where this one has two terms, so we look at each term to see if we can find anything in common, where we want to find the greatest common factor. So when I look at them, first we look at the numbers 28 and 21. So this is something we discussed before during the first week of the class, that how to find the GCF, greatest common factor of two or three numbers. If you are able to see that, you can just go ahead and write down. So the GCF for those two numbers, as we can see, 7 goes into both of them, and the 7 is the greatest. If you don't remember how to do that, and go back to the video, so you can either list all the common factor, all the factors of each number and find the one in common, or you can use factoring tree to help you find the greatest common factor. So now we can look at the variables. So a third and a squared, what do they have in common? So if you follow the tip, you are from the previous video, you're always going to take the lowest, the one with the lower or lowest exponent. So a cubed and a squared. And when you think about it, it makes sense, because a cubed means we have a times a times a, three copies of a. But a squared means we have two a's as factors, two copies of a. Of course, they're going to have, when you bring down one from each row, you're going to find, not from each row, each column, I'm sorry, from bring down the common factors that appear in both of them, that would be a and a. So they will have two in common. And similarly for b squared and b squared, they both have two copies of b, so they have b squared in common. So if you have trouble seeing the common factor for the letters, the variables, you can expand them to bring down the common ones. Okay, so now we write down the greatest common factor, 7a squared b squared. And the next thing is to figure out 7a squared b squared. If we factor this out from each term, what's gonna left for each term? So the quickest way to do it is take the original term. So that's the first term, 28a cubed b squared, divided by the one you're going to take out. So this is the GCF we're going to factor out. And we already talked about how to do division of monomials. So you're going to do 28 divided by 7, a cubed divided by a squared, that gives us a, b squared divided by b squared, they cancel each other. So we get a 4a for the first part. And similarly, you can take for the second term, we divide by the GCF. 21 divided by 7, that's 3. A squared divided by a squared, they're canceled. B squared divided by b squared, they're canceled. So you're just going to be left with a 3 there. Okay, so that's the final answer. So this is what we want. So be careful. You don't need to multiply them out because this is not a multiplication question. This is a factoring question. We want your answer to be something times something. But if you want to check your answer to make sure you did it right, you can multiply them out. So for example, 7 times 4, it's 28, a squared times a cubed, b squared, just put b squared there. And then we distribute 7a squared b squared to 3. That gives us 21a squared b squared. And that matches the problem given, so which means this factoring is correct. But if you want to check your answer, make sure you put a check in front of it, and it's not that this is not the final answer. This is just checking. This one is the final answer right there. Okay, now let's look at the second problem. So sometimes the greatest common factor, the one we have, 7a squared b squared, it's a monomial because there's no plus or minus. But it's possible the greatest common factor, it could be a binomial, or it could be a trinomial, as long as they match. That's a greatest common factor. So it could be a binomial. So in this case, if you take a look, there are two terms. because x times y minus 2, it's in the parentheses, we treat as one factor. So x times, because between them it's times. So that's a factor, that's a factor. So between them, if you multiply two factors, we just get one term. So this is our first term. And similarly, 3 times y minus 2, that's our second term, because it's multiplication between them. So y minus 2, you would treat it as a factor. Okay, so if you recall the definition previously, when we say factors, it's always, 2 times 3 or x times y. You call 2 a factor, 3 a factor, x a factor, y a factor. But even if I change this y to y minus 2, that y minus 2, it's still considered as factor as long as it's multiplication between them. Okay, so in this case, when we look, we found, well, they both have y minus 2. And so the GCF is going to be y minus 2. And we can factor y minus 2 out. So let's take y minus 2 out, this and that. And we can do it directly. If you take this out, and the first term will be left with just the x. If you take y minus 2 out of the second term, you're going to be left with a plus 3. So that would be the final answer. And if you want to check your answer, again, you are going to distribute. You can distribute everything out, and you can also distribute this out to see if they match. And the other way, you can do something similar, like if you say that's our first term. When you take y minus 2 out, when you factor this out, and they cancel each other, that's why you left with the x. And similarly, for the second term, when you factor y minus 2 out, and this will be canceled, you will be left with a 3.